Hi class, and welcome to the next lesson on 9.5. What we're talking about in this lesson is we're talking about graphs and equations of various functions. So we've talked about a variety of functions so far this year, and we've talked about their graphs and their equations. We've done this in each individual chapter, and now we're going to kind of lump them all together and see if we can differentiate between them. So what I like to compare this to is the name of a function. Let's just say it's the name of a friend or the name of a person, okay? That's what this part is. The name of a function, it's just their name. A graph is kind of like a picture. So if take a picture of one of our friends, or take 3 pictures of this cutie, for example. If you just look at the picture, what is that little boy's name? Well, obviously for me, this is my son. So I look at these 3 pictures, and I know exactly, just by looking at the picture, that this little kid's name is Matthew Berge. Just by looking at those pictures, I know the name. So that's kind of what the graphs do. The graphs is kind of like a picture. What is that name? So now the equations, we were able to look at y equals mx plus b, or y equals ax squared plus bx plus c. These are the equations. These are like certain qualities about them. So if we go back to our actual people example, qualities would be like, this person is 2 years old. This person enjoys playing at the park, and this person loves playing in the fall leaves. What person does those things describe? That person, there it is my son again. He's 2 years old. He loves playing in the park. He loves playing in the fall leaves. He just has a good time doing that. So this describes my son. Who is my son again? What is his first and last name? It is, once again, Matthew Berge. So what we're going to be doing today is we're going to be looking at pictures. And we are going to describe, or we're going to list the name of the function that we're talking about. We're also going to be looking at equations which tell certain qualities about that function. And then once again, we're going to list its name. So that's going to be our objective for today. So here's the first one. This one, what is its name? Well, it's U-shaped. It has a minimum. It crosses the x-axis twice. This is a parabola, so the actual function is a quadratic. Quadratic is our first one. For this next one, this one has a relative maximum, it has a relative minimum, it crosses the x-axis 3 times. What kind of a graph, what kind of a function is that? It is a cubic function. First one quadratic, second one cubic. Third one, this is the one that we are studying this chapter. It has a horizontal asymptote as x equals 0. It has a vertical asymptote at x equals a negative 1, this is the horizontal asymptote of y equals 0, vertical asymptote x equals a negative 1. This is our rational function. We're studying it this chapter. Rational function. For number 4, this one is half of a parabola. What are those half parabolas again? Those are called the square root function. So this one is a square root. Once again, we're looking at pictures and we are telling what their names are, or what kind of a function is it. This one, y equals mx plus b, it has a y-intercept of a negative 2, and then it goes down 1 over 3, so it's a slope of a negative 1/3. This is our linear function. Linear. Number 6, this one is also U-shaped, except that it opens down instead of opens up. This is another quadratic. This is a quadratic. Moving on to number 7. We haven't dealt too much with this. We did a little bit in chapter 2, but this is sometimes abbreviated or called the step function because these look like steps, but the actual name for it is the greatest integer function. The greatest integer. Moving on to number 8. This one is, once again, there's an asymptote here at x equals a positive 3. So when we have asymptotes, these are our rational graphs. A rational function. That is the answer for number 8. For number 9, our v functions, whenever it forms a v, these are absolute value graphs, or absolute value functions. whoopsie, absolute value. All right, now that you've kind of got an idea about what I'm looking for, why don't you guys try the next 9 on your own? You're looking at pictures. Tell me what its name is, or tell me what the function is. So pause the video, try the next 9, and then check your work with mine after you're all done. Okay, this one is a linear function. I would accept that on a test, but if you want to be more specific, it's actually called a constant function. So either one of these I will accept on a test. It's the function y equals a -3. And because it's always or constantly a -3, it doesn't have a slope, we call it a constant function. But if you called it a linear function, I'm just fine with that as well. Either one, I would count right on a test. For number 11, hopefully you put quadratic. Number 12 is cubic. When it has this doohickey thing right here, that is called our cubic function. The V-shaped graph, those are absolute value. (14), you should see 3 zeros when it crosses the x-axis 3 times. Those are our cubic functions. Cubic functions also have a relative maximum and a relative minimum. So those are 2 giveaways that gives that that's a cubic function. Next one, this step function again is called the greatest integer. Moving on, this one has asymptotes at a -3, and it has an asymptote at 0, and it has a horizontal asymptote at y equals 0. So all of these asymptotes tell you that this is a rational graph. Rational. 17, hopefully everyone got this one right. This is our linear function. And the last one, 18, this is our sideways parabola again, and it's half of a sideways parabola, which means that it is the square root function. So you're going to have some test questions like that where you're going to look at a graph, you have to tell me what function it is. And now the next type is we are going to see certain equations. And looking at those equations, it's beneficial to know exactly what type of a function that is. Are you looking at a rational? Are you looking at linear, quadratic, so on and so forth? These are some hints that are going to help us along the way. If it has a degree of 1, it's going to be linear. Quadratic has a degree of 2, which the degree, as a reminder, is the highest power of x. If it has a degree of 3, that's our cubic function. That's as high as we go there. If at any time there's a denominator where there's a variable in the denominator, these are called rational functions, because there's going to be an asymptote somewhere or another with our rational functions. A square root function, well, obviously it has the square root symbol. Likewise, the absolute value, it has the absolute value symbol. So hopefully those are dead giveaways as we go through these. Okay, so for the first one, when I look at y equals 2x squared minus 3x plus 8, I see that my degree is 2. If it's x squared, this is our quadratic. So for number 1, the correct answer is a quadratic. For number 2, I see x cubed. If I see a degree of 3, it's a cubic function. Number 3, I see variables in the denominator. If there's a variable in the denominator, I know right away this function is rational. Moving on, number 4, square root symbol. There's our square root function. Number 5, even though it doesn't go in descending order, you got to look at the degree. What is the degree? It is squared. So if it's a squared term, you know that's a quadratic function. Number 5 is a quadratic. Moving on, number 6. This is y equals 7. If you have linear, I'm okay with that. But once again, this is a function that at 7, it's a completely straight line that goes horizontal, which means that it is a constantly 7. So it's a constant function. Either one, linear or constant, I would accept right on a test. Number 7, y equals 6 over x. There's a variable in the denominator. If there's a variable in the denominator, it is going to be a rational function. Number 8, absolute value symbol. Dead giveaway. The absolute value symbols means it's an absolute value function. And then number 9, y equals x cubed. That x cubed tells you that that is a cubic function. So once again, why don't you guys pause the video, try to do the next 9 on your own again, now that you have an idea of what I'm looking for going through these. Number 10, you should have had linear. Number 11 is quadratic. Number 12 is x raised to the 6th. If we had to be specific, we would call this a polynomial function. But at the top, it has to be one of these. So this one would be none listed, because it's none of these ones that are up here, so it means that it's none listed. Normally we would put polynomial, but because polynomial isn't one of the options, we would put none listed. 13 is the absolute value. 14 is none listed again, because it's x raised to the 4th power. 15 is linear. 16 is rational. There's a variable in the denominator. 17 is linear. It's y equals mx plus b. And then 18, you see a square root, so it's a square root function. So this is so beneficial for us because sometimes on like an ACT or an MCA type question, if it gives you this as an equation, and then it's an A, B, C, D option type of a test, where if they have, here's A, B, C, D, and they might have A that looks like this, B that looks like this, C looking like this, and D looks like this. Well, if you look at all of these, you know that it's the square root function, so that means it's not a quadratic. There's our quadratic. It's not a sideways parabola. It's not a cubic function, so the only one left is this one. You don't even have to put this into your calculator and solve for that graph and so on and so forth. You just know it's this one. So that's why this lesson is so beneficial, to help eliminate some options right off the bat. Alright, so now to finish this lesson off, the directions on this part is to write an example equation for each of the following, then sketch the graph of your equation. Just for the sake of consistency, why don't you guys write down these 6 problems just how I have them up here. If we have y equals 3x plus 2, it has a y-intercept of 2, and it's a rise of 3, run of 1. Draw your line. You could pause the video if you need more time to sketch these. I'm going to go relatively fast just so that we can save time on the video, but certainly feel free to pause the video and to sketch these if you need more time. So this one is our parabola. You could find the vertex by doing a negative b over 2a and then substituting to find the y coordinate, so on and so forth. But here would be an example of a parabola. And there's infinitely many parabolas, infinitely many quadratic functions. This is just one that I've decided to pick for this problem. Next one. This is our cubic. It crosses the x-axis 3 times. It crosses at 0, -2, -3. It has a relative minimum. It has a relative maximum. So this would be an example of a cubic function. Going on to our rational function, that's where there is a radical in the or a variable in the denominator. So we're going to have a vertical asymptote at x equals a -3. So that's going to be right here. If you put this in your calculator, you're going to get a horizontal asymptote at y equals 1, and you're going to get a function that looks like that. 2 more. For number 5, the square root function. This one is going to start when our radical is 0. So when does x plus 3 equal 0? When x is a -3. So that's where it starts. And then it also goes through -2, 1, 1, 2, and at 6, 3. And then you connect the dots. And the last one, just an example of a absolute value graph. X minus 2, it's going to start at a positive 2, and then the slope is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Same thing as up 1, left 1, up 1, left 1, up 1, left 1, and then you get your v function. So those are just a few examples of looking at a graph picking what type of function it is and looking at an equation and picking out what kind of a function it is. You're going to have several of those questions on our next chapter test.